One recording. Yep. All right, so we got the limit as x goes to 0, 4 sine of 5x over 3 tangent of 4x minus 1. Okay, yeah. Never not first, right? Never not first, direct sub. We get sine of 0, which is 0 times 4 is 0. And then here we get tangent of 0, which is 0 times 3 is 0. So on this piece alone, we get 0 over 0. And what do we get when we plug in a 0 over here to a 1 that doesn't even have a variable? We get 1, right? So the limit of a constant is a constant. So we can use the property from 1.2 that says the limit of a sum is the sum of the limits, or the difference. So look at this. I've already done the second one, right? That was easy. I just threw that in there kind of as a little funny haha. And then this one, the 4/3 is going to go along for the ride. It's just a constant multiple. So really, it's just this. What is the limit as x goes to 0 of sine of 5x over tangent of 4x? 5/4. It is. And it is by memorization, right? Yeah, it's a big time saver. You don't have to manipulate the expressions. And so on a free response, could we stop here? Yeah, free response, you're done. Otherwise, we keep going. We get 5/3 minus 1, and 1 is 3/3, so we get 2/3. There's the answer. Ta-da! Yeah. Okay. So I hope you've been doing the worksheet as you've been going, especially like this kind of stuff, because you're reinforcing all that trig stuff, and I have you kind of memorize more than what's needed for the AP exam. But we did have a math club meeting yesterday after school, and it was kind of under-attended, and it's kind of my fault for not advertising, but it was on the announcements today, and maybe you heard about it. So we're going to meet in here every other Wednesday, and here's the deal. We decided that it would be best to meet during advisory right now. So every BC Calculus member is invited to join the math club. And I thought it would be a good break since we teach every day during advisory. Every 2 weeks on a Wednesday, we won't teach BC. So if you don't want to be in math club because it's against your family's heritage or that, I can't bring that word up in a public school, Ben DeLay, but I'm glad you did. If you don't want to be in math club, then you can leave this classroom during advisory and you can go to Miss Lincoln's house and pull weeds in her backyard.
I love a little bit of yard work. Does she live near here?
She lives over yonder.
I love a little bit of yard work.
Okay. So, but seriously, if you don't want to be in math club, you can sit in the back corner quietly and just kind of like, you know, maybe be persuaded to join because it's going to be awesome. Or I'll open the math closet for you where there's no air conditioner, and we'll just set up a couple chairs in there. Okay. All right. Anyway, let's move on. We are on example 15f. 15f. We got the limit as x goes to 0. Surprise, surprise. But we've got a couple of different looking trig functions here that we haven't seen before. So, well, we have seen before, but not in this section. Cotangent of 11x over cosecant of 25x. Never, not first, direct sub. 11 times 0 is 0. What's cotangent of 0? Very good, because it's some type of what? Infinity, right? If tangent of 0 is 0, cotangent is reciprocal, and the reciprocal of 0 is some type of infinity. Plus or minus, we don't know unless we investigate on either side. But we're not concerned with that. Cosecant of 0 is what? It's also DNE because it's some type of what? Infinity. Infinity over infinity. Is that 1? No. Is it determinable? No. It's the reciprocal of 0 over 0. So this is one of those 3 indeterminate forms we've talked about. 0 over 0, infinity over infinity, and then yesterday we saw infinity minus infinity. Just 3 different sides of the same coin. Yeah, there's a third side to a coin. It doesn't usually land on the rim, but it can. All right. That would be an awkward Super Bowl flip. Okay. So what can we do? What can we do? How do we proceed? How do we get it done? Turn it into sine and cosine. Let's explore that. I'm going to call this the left fork. Okay, the limit as x goes to 0. Cotangent would be what? Cosine over sine. And then cosecant would be 1 over sine of 25x. And now we have a complex fraction, right? Hooray, yes. Oh, that would be the right fork.
Well, so
Oh.
you could flip the cotangent and cosecant, so then it would be just sine over tangent.
That's the right fork. Boom. All right. I wasn't going to shut down that idea, but that's what I'm going to suggest. So let's do it this way. Yeah, very good. Putting in terms of sine and cosine, like trig proofs, it's good. It's a good thing to do. We have a complex fraction now, right? We said yesterday, hooray, hooray, we say today, because we created a complex fraction. And we know what to do next algebraically, and that's to eradicate it, right? Now, instead of doing lick'em over lick'em here, because these two are co-prime, we could just do state change flip if we wanted to. State change flip. All right, state change flip. So we got stay in the top, cosine of 11x over sine of 11x. As a 0, right? Stay, change, flip, we get sine of 25x over 1. And now we plug in and we get 0 over 0, which is another indeterminate form. It's the reciprocal of infinity over infinity. But now I think at least we have it, yes? By the associative property, without even regrouping them, we can associate those together. And what is the limit as x goes to 0 of sine of 25x over sine of 11x give us? 25/11ths. And then how do we evaluate cosine of 11x at near 0? Direct substitution. Yeah, so cosine of 0 is 1. All right, so 1 times anything is itself. Boom. So that certainly works. Abso-positively it works. Good. Excellent. Now, there is another way to do it, okay? And it is to, because these are factors, you could call cotangent 1 over tangent instead of cosine over sine. And you can call cosecant, of course, 1 over sine. But because they're factors, you could just do like the double flipperoonie. And that's what I'm going to do over here. A cosecant factor in the denominator is the same as its reciprocal sine factor in the numerator. Okay? And a cotangent factor in the numerator is the same as its reciprocal factor tangent in the denominator. So it's like calling it 1 over tangent and 1 over sine and then doing state change flip. Okay? It just works a little bit faster when you have factors, not terms. Any trig function is its reciprocal on the other side of the fraction. Okay? And now you can look at it and say, ah, it's 0 over 0, which is kind of evidence that infinity over infinity and 0 over 0 are reciprocals of each other. And now it's in that recognizable form, 25/11ths. So which method is correct? Both, yeah. So anyway, whatever you, yeah. Where did the what? This one? It's from here. Oh, it's this. It's cosine of 11. It's when I plugged a 0 in here. 11 times 0 is 0. Cosine of 0 is 1. I didn't need to write it. I just did it for inventory purposes. Yeah. Here, let me color code them deliberately there. Yeah. You don't need to do that. But it's funny how we eradicate the 0 over 0 problem. Then sometimes people are faced with like cosine of 11x near 0, and they're like, what rule do we learn for getting rid of that? It's like, plug it in, right? He's harmless. He's not causing a 0 over 0. He's causing a 1. Yeah. All right, cool. Boy, that opens a whole nother can of worms, doesn't it? If we've learned it with sines and tangents and combinations, we can modify that to any combinations now of cotangents and cosecants, can't we? Wow. I'm not going to write that out. Let's jump down here. Look at this. If you're ever taking the limit as x goes to 0 of a ratio of cosecant to cosecant, cotangent to cotangent, or any combination of the two, it is not m over n as you would normally do for tangents and sines. It's the reciprocal n over m. Now, if I had just thrown this at you, you would have probably rebelled, right? Because it's a lot to memorize. But we've been kind of developing all of this in context through examples. So hopefully you've been memorizing as you go. So if you know the line above it and you realize what we just did with the double flipperoonie, then you really don't need to memorize this. You can just utilize the line above. Right, Mason? Are you okay? Do I need to send you down to see Miss Kinsey's therapy dog, Hank? Yeah, or I can send you over there to see Hank. Right. He's like a therapy dog.
Doing better than yesterday.
Yeah.
Hey, Mark.
Okay. Let's try this one. Now that we know that rule, let's try this one. Go. The limit as x goes to 0 of that. On your mark, set, go. While y'all are doing that, I bought 2 more boxes of Popeyes, but they're not frozen yet. I just put them in this morning. So by this time tomorrow, you can have your greens and reds and oranges again. And clean up after yourself if you're over there. Some people left the dirty wrappers out and the scissors out yesterday. Don't do that, or I'll have to cut you off.
It was not me. I didn't have one yesterday. I didn't even have one yesterday. All right.
Let's see. A, B, C, D, F, G. Oh, you got 9?
I don't know. Maybe.
No, it's not an illusion. So how'd you get 1? You used direct sub? Yeah. How'd you get 9?
But it doesn't have a variable, so what I got.
We didn't learn that. No, you would just use direct sub. Sine of 0. And now. Mm-hmm.
So is it I can see 0. So it is 0. Well, we found our 0, guys. What?
And the sign of 9x. Now it's not 0.
Yeah.
Oh, wait, hold on. Okay. But then I need it. Basically, yeah, it is. So if I have whatever 9x there.
0.
Oh, no.
It's 0. It's 0 to 1, right?
Good convos, I hear. Good convos.
Did I get funky with it? Cosecant is 1 over sine, though, right?
It is.
1 over 1 over sine, which is the same as sine over 1 is 0 over 1.
All right, most of y'all are coming up with some kind of conclusion in some fashion, form, or other. This kind of problem makes a great multiple choice question because I can have answer choice A, 14 over 9. Answer choice B, 9 over 14. Answer choice C, peaches. Answer choice D, 22. And answer choice D, 0, which would be the correct answer. Yeah, I might put D and E on there as well. Now, instead of peaches, what if I put Harry Styles? Would that be more tempting? Anyone going tonight? Harry Styles concert tonight.
Wait, where is it?
It's in San Antonio. My daughter, she's going tonight, and she had a ticket for me until she went to college and met some friends, and now I don't get to go. Now she's taking her friends. But yeah, she's skipping class tomorrow in Nacogdoches to come home tonight to go to Harry Styles. Yeah. Whoa. So never not first, Mason. Respect the recording. No, never not first, direct substitution, right? Cosine of 0 is what? 1. Cosecant. Cosecant of 0 is what? Cosecant of, it's D and E because it's some type of what? Infinity. Now, sometimes it can be plus or minus. Now, is 1 over infinity indeterminate form? No, it's a determinate form. What is 1 over infinity approaching? 0. That's the quickest, fastest, easiest way to get the answer. Yeah. 1 over infinity approaches 0. Okay. So that's one way to do it. Here's another way to do it. It's not 14/9 and 9/14. Here's what you want to do. Just because you see the limit as x goes to 0 and you see trig of something over trig of something, it doesn't mean it's the ratio of the angle's coefficients. Okay. Let's see. Some of y'all put it in terms of sine and cosine, and I saw you put like 1 over sine. But remember, you can bring that straight to the top in the next line without doing 1 over sine, because the cosecant in the bottom factor is the sine in the top. And now direct substitution gives you 1 times 0, which is 0. Yeah. There you go. So, nice. All right, so right on the heels of teaching you a new rule, I try to bait you into using overgeneralized stuff, and really, y'all didn't take the bait. All right, so now that you know a little bit more than you did when you were younger a couple of minutes ago, do H on your mark and set go. H for Heliostats. All of them. I know all of them. I like Falling. I like ballads. Adore You is my favorite one off the newest album. There you go, Mason. What's yours? Oh, it's all right. Mendeley, talk Kiwi after you get an answer. All right. I told my daughter she had to do her stat homework first before she could skip class tomorrow. So math comes before Harry Styles. Yeah. All right, advisory's over. If it was a math club day, we'd be ready for calculus. I'd take you out of the closet right now.
It's also 0. So,
Direct substitution, right? Never not first. Cosecant of 0 is D and E because it's some type of infinity. Sine of 0 is 0. Is infinity over 0 indeterminate form? It's determinate, yeah. So you could do it over here. You could either bring the 0 to the top. What's the reciprocal of 0? Infinity, right? So what would infinity times infinity be? Some type of infinity. Do we know which type for this general limit? No. So what can we put safely? No, you don't put two answers. You put D and E, or if it happens to be up on both sides or down on both sides, only then could you put plus or minus for the general. But that would take a little bit of investigating. We don't want to do that. Or you could bring the infinity to the bottom, and now what's the reciprocal of infinity? 0. And now you'd have 1 over 0. What's 1 over 0 another name for? D and E, because it's some type of infinity. Non-zero or 0 means vertical asymptote. So that's probably how I would do it. The answer is D and E. Okay? It's not 7 over pi. It's not pi over 7. 0 over 0, infinity over infinity, and infinity minus infinity. Those are the only three indeterminate forms we'll have right now. Everything else is determinable, right? Okay, since I brought up Harry Styles accidentally, let me just tell you the one time I gave my daughter the best birthday gift ever. I actually paid to have Harry Styles come to my house in New Braunfels and reenact the album cover on my coffee table in the living room. Right? Yeah, I know, right? It's amazing. Yeah. You probably have seen that. That's right. Yeah. Yeah. My dog is not amused in the background. See? Yeah, that's right. This was on the 10-year anniversary of One Direction. So I went to the 1D concert with her and I had a blast. I wasn't the only dad there, but you could see obviously that I had my outfit picked out for tonight, but I guess I just have to wear it around the house, you know? Yeah. Hey, maybe someday. Maybe someday. Yeah. Those are, no, because those are white jeans. I've already got a pink out costume. Trust me. What? Oh, yeah. Yeah. No. All right. So anyway, yeah, there's that. So I didn't get a chance to wear it tonight. My daughter, by the way, has already bought 5 outfits to wear tonight. So I don't know what she's going to wear.
She's gonna wear them all. It's a new generation.
Well, it's kind of hot, but it works. All right, letter I. Letter I. Hey, look, letter I. I did something fun here. I changed X to T. Ooh, that's about as fun as it gets at a math party, right? Not at a math club meeting, but at a math party, right? Like when the faculty gets together up here, it's like, woohoo. No, we're actually a pretty tight group up here. Okay, yeah. We have a good department up here. What does sine squared of 2t mean? What are we actually squaring? The n or the whole sin? The whole thing. Good. That's the abbreviated condensed version for sine of 2t quantity squared, right? So this is really useful for like final presentations in this condensed form. It's useful if you're traveling on a plane because it condenses down. You can put it in the overhead bin a lot easier, less space. But if you're going to be using it, you're going to want to write it in expanded form, okay? Because it's more meaningful. And in the bottom, we have 3t squared. So now never not first. What do you get when you plug in a 0 for t? You get 0 in the top, 0 squared, which is 0 over 0. Hooray, hooray. Yes, we get to do more stuff. Now, it has trig in it. We're approaching 0. We memorized a couple of things, right? The one with sine and the one with cosine. We're probably going to have to use the one with sine here. Yes? Yeah. So, yes, question? Oh, squared. Yeah. Is it 2/3 squared, 2/3 quantity squared, 2 squared over 3, 2 over 3 squared? Well, let me just tell you that you got to be careful, right? Same advice I'm giving my daughter tonight when she leaves, okay? Don't go home with any boys unless it's Harry himself. And then invite me because I need to be there as well. This is sine of 2t over t quantity squared, okay, times 3. Yeah. See what I did there? Now, let's do it differently. When in doubt, expand it out. When in doubt, expand it out. So that's sine of 2t times sine of 2t all over 3 times t times t. Is it okay? Yeah, yeah. Now, look what happens. This is really a 1/3, yes? What does sine of 2t over 1t approach by memorization? 2 over 1, right? And what happens to this one, 2t over 1? It also approaches 2. So what's the answer? 4/3. I ran out of room, so I went horizontal there, okay? It's 4/3. When in doubt, expand it out. Because if you tried to like do it by looking at it, you might be squaring the wrong thing or not squaring what you're supposed to. Now, there is a shorter way to do that. Let me work left to right here. If you group together the things that are causing the zeros, which is the sine of 2t in the top twice and the t in the bottom twice, you can group them together like this and say it's sine of 2t all over t quantity squared, right? That uses the rule of exponents. When you have a quotient squared, it's like the numerator squared over the denominator squared, and then that would just leave a 1/3. This would also work, right? Because now what's the inside here? This is like property 1.3, I think, in 1.2. We get 2 over 1, which is 2. But what are we doing with it? Squaring it, yeah. So it's 2 squared times 1/3, which gives you the same answer. Okay. But when in doubt, you can expand it out. Now, I wouldn't recommend that if this had been like sine to the 22nd power over t to the 22nd, because that's a lot of things to write out. So it's kind of nice to know this general rule right here. But I don't think you're going to see powers that large. Okay. Got it? That make sense? All right. So hopefully the t didn't throw you off. Okay, cool. Cool. Now, jump over here. You get the idea. On your mark, set, go. You do it yourself. J for Jenna, my daughter, who's going to see Harry Styles tonight. If it would have been a year ago before she went to college, I would have been there, but they canceled because of the pandemic. So I don't get to go. I'm going to have her buy me a t-shirt, though. I won't wear it tomorrow, though, because tomorrow's blue out. Blue out tomorrow. Right, Ethan? Is the entire blue crew blacking out?
No, I'm the mascot.
Hey, what?
What?
What are you talking about?
Dude, next thing you're going to tell me is like Santa Claus isn't real.
They announced it during the game.
Really? Yeah, they
They announced the mascots.
All right, don't ruin the tooth fairy for me. What's the answer, everybody, real quickly? Is it 2/5?
No.
Times 2? Squared. Right, squared. So again, if you want to write it like this, it's sine of 2x over sine of 5x, which would be 2/5 squared. And so, yes. Yeah, we wrote that, but that would be this rule here. Any combination of sine and tangent, tangent and sine, tangent and tangent, and sine is just a over b. Okay?
That's what I did.
Yeah, because there you go. I was answering her question in my head. I made a careless mistake at the end.
That's what I got. First one right.
Good. No, that's when in doubt, expand it out. And you weren't even in doubt. It's just how you wanted to do it. Perfect. All right. Let's do letter K for Corpy, right? As in Jenna Corpy, who's going to see Harry Styles tonight. By the end of the night, maybe her name will be Jenna Styles. In which case, I'll be a father-in-law. Tomorrow. All right. All right, go. What'd you get? What'd you get? What did I get? 2?
What did you get?
Did you also get 2? Oh, you're working on it. Okay. I just guessed that. I saw the 2 up here and I was like, 2.
Are you
All right,
coming back?
we'll see you. He's coming back Monday. Yep. Come on, focus, focus. It's not just a small Ford sedan. It's something I need you to do. The Ford Focus. It's a very responsible car. Yeah. F-250, right? Or they make 450, 550s. No, you got a great idea. That's the answer. Yeah, no, it's not. Yeah, that's right.
It's 3-1.
Right?
Need I, thank you. Need I remind y'all, never not first. Gosh. Direct substitution. E to the 0 is 1. Cosine of 0 is 1. 1 squared is 1. Secant of 0 is 1. So we get 11 over, no, we get 1 times 1 over 1, which is 1. The answer is 1. 1. That didn't require anything fancy. That's just direct substitution. Never not first. Yeah. Okay. All right. Letter L. Let's do this one together. All right. Direct sub. We learned our lesson, didn't we? Fior minus fior is 0. Tangent of 0 is 0. So this term is 0. 8 minus 8 is 0. The absolute value of 0 also 0. 0 plus 0. I'm no fool. That's 0. Now, just because we get a 0 on the top doesn't mean it's going to be indeterminate, right? If I get non-zero on the bottom, it's 0. 4 squared. 16 minus 4. Oh my gosh. That would have been embarrassing if y'all started doing all kinds of other nonsense. Right? Yeah.
I really wanted to do that problem. I wanted to work it.
Where are you?
Yes, I'm Nah, bro, I saw 2.
Yeah. Okay. Everyone good with that? Now I'm going to backtrack and I'm going to change it. And I'm going to change this from a 4 to a 16. And now we still get 0 in the top. And what do we get in the bottom? 0. Okay. So now it's a problem that's worthy of attack, right? All right. So, man, I got some cool things happening in the top. I got a trig function and then looks like an absolute value, which is part of Jumpman, right? What can we do here? What strategy I already talked about so that I can divide and conquer? What's that? Separate it. Separate it. It's a strategy, right? We can separate numerators by putting any combination of numerator terms over the entire denominator. So let's see what that's going to look like. The limit as x goes to 4 from the right, parenthesis, I get tangent of x minus 4 over. I'm going to go ahead and factor the bottom. Is that okay? Yeah. Difference of squares, x minus 4, x plus 4. So there's that one. And then plus the absolute value of 2x minus 8 all over, same thing, x minus 4, x plus 4. We'll use that strategy quite a bit this year, separating. And again, you need parentheses around both quantities now unless you feel like writing the limit twice in front of each term. Divide and conquer, right? So it seems like it's twice as much work because it's 2 problems now, but the work is 4 times as easy, right? Yeah.
Is this not, I can't do it?
No, because in what? Well, where'd the tangent even go? Ah, no, you cannot do that. But no, she was saying if the tangent weren't there, could you divide out one of the x minus 4s here? And the answer is not in that case because the x minus 4 on the top would be a term, not a factor. Now, once you split it up, if it were x minus 4, then you could divide it out. But yeah, the tangent is there. And he takes issue if you just ignore him, okay? As most British people with dark skin do that have been on the beach for a long time. That's a very subtle tangent joke, right? You know who else is a tangent? Huh, you started! Well, you know, I just went with it. Look at this. We need to group together or associate. We need to associate. Ben delay face forward. Leave Ben delay alone. We're going to group the pieces together that are causing 0 over 0. In the first term now, I've done that, right? In the second term, it's going to be this and this. Both of those, we have memorized methods for eradicating the 0 over 0, right? Both of them. So let's go ahead and use them now. What is the limit as x goes to 4 from the left, right, or general of tangent of x minus 4 over x minus 4? 1. Good. Because this would be the horizontal shift to the right. What used to happen at 0 is now at 4. So it's 1 over 1. So that's 1. Okay? So I get a 1. How do I then evaluate what I didn't highlight in that term? Plug it in, right? 4 plus 4 is 8. So I'm left with 1/8. Or just 1 over 8. Got it? Plus, how do I eradicate the 0 over 0 problem here? Jumpman. So just into the highlighted piece, I can plug in a 5 or 6. Let's plug in a 5. 10 minus 8 is 2. The absolute value of 2 is 2. 5 minus 4 is 1. How do I evaluate the non-highlighted piece? Do I plug in a 5 also as well to here? Here. I plug in a 4 and I get an 8. Very good. The different number trick only works on the Jumpman piece. Okay. And now on a free response, it's like, I don't think so. You grade this, College Board person, which I did for 6 years. Right. This is why they hire math people to grade the test, because they look at that and like, oh, that's the right answer. Okay. Yeah, as long as you're not the man you're sticking it to, right? Now, I'm not going to simplify 2/8 to 1/4 because I need a common denominator. 3/8. There's your multiple choice answer. There you go. So the original problem was direct substitution, but changing the denominator to a 16 makes it a little more fun, right? A little more fun. A little more fun. See how much easier it is to learn when it's not loud and we're all focused? Now, sometimes I'm the guilty party. Sometimes I'm like, hey, I'm the bus driver. And then as I turn around to quiet you down, I realize I'm going off course, right? Like, oh, I was the cause of the all going off course. And I apologize for that. But if I do redirect you, you need to be like, yep. All right. What's that? You don't understand the bus driving analogy? No. Oh. So you did not sing. You did not sing to the bus driver? Hail to the bus driver, bus driver, bus driver. Hail to the bus driver, bus driver. Woman, she drinks, she cusses, she makes I was going to say she makes them late. Because y'all were kind of late getting to the game last Friday. Yeah, so we're trying to fix that. We thought we were going to have to take Buford out there ourselves, you know. I do. That'd be cool if I actually drove Buford. Like I got on top like a saddle and be like, come on, Buford. That would be cool. You know who can help me realize that dream? Ethan's dad. Ethan's dad, get this, Buford handlers. Ethan's dad had this idea of taking Buford's horn, putting a hinge on it so you can open it up, and boom, he fires T-shirts out of the horn. Yeah, he actually built a prototype cannon that he could put inside Buford's head. And then I was like, wouldn't that hurt Buford, I asked? Because Buford's real. Yeah. Yeah. All right. Here's the summary of everything that we've kind of learned. And if you memorize these, it's going to make life easier for you, okay? You don't have to justify or show any work if you have these memorized. You can go straight to the answer. Okay? Do you have to memorize those? No. How much time do we have?
Just about 8 minutes.
Oh, okay. All right. I'm still on, like, I don't know, looking here for like a clock or a schedule or something. All right. I don't know. I was looking for like what time and then the clock, but I ended up looking here instead. General cleverness. When all else fails, we don't give up, right? Sisu, baby. Sisu. We persist. And so it's up to us to get the job done. Theodore, not Teddy Roosevelt. You don't want to call him Teddy to his face. He said, first say that the job can be done, and then figure out a way to get it done, right? So that's what we're going to do here. Yes, we're going to get all these done. I don't know how, but we'll make it work. Okay. This is a great method to use when all else fails, right? So here we go. DNE.
It's really funny because I did that.
Oh, that is the exact opposite of Sisu. That is copying out. What is Sisu?
Oh, yeah.
Look it up during lunch. It's right here. Sisu. Yeah. Yeah, read it to us. Read it to us.
Did you not have it last year?
No, she didn't. No. Like, you were the only one in here that did.
Wait, really?
And JT, no, and she did. Yeah. And he did. Yeah. So about half of you.
Yeah.
Read it. Hang on. Read it. Read it. Here's Sisu. Read it loud. Here, into the microphone. Read it.
Say it with your chest.
Oh, I'll get it. Yep. Here we go. Sisu. I'll hold it. You just like a microphone.
A Finnish concept described as stoic determination, how do you say that? Tenacity?
Yeah. That's the word.
Of purpose, grit, bravery, resilience, and hardiness, and is held by Finns themselves to express their natural.
You know what the definition of Sisu is? Making your way through reading that while you're laughing. I mean, it took a lot of Sisu. Yeah. Sisu is what Jaime Escalante called ganas. Yeah. I like to explain it this way. It's what my Finnish grandfather had to do to coax potatoes out of the frozen tundra in Finland. Yeah, see? So I've said it before. Yeah. All right. The limit as x goes to 0 of 5x squared over 1 minus cosine of x. We've learned our lesson. Never, not first. I get 0 over 0. Yep. Now, hey, look, we've kind of memorized something like this with an x and a 1 minus cosine, right? Remember that? Let's see what that was. It was right here. Hey, we said it was D and E if it was just x over 1 minus x, because it's some type of infinity. So is this D and E? Well, hang on. Yeah, it's squared. I noticed that too. So let's go ahead and let's split it up. Let's call this x over 1 minus cosine of x. That's the 0 over 0 problem, yes? Times 5x over 1, the non-zero over 0 problem. That's just the associative property of multiplication. Now by direct substitution, the first factor gives us some type of infinity. And by direct substitution, the second factor gives us what? 0, right? 5 times 0 is 0?
Yes.
So I end up with infinity times 0. What is infinity times 0? 0? You think 0 can overpower infinity? Yeah, we have. This is the ultimate like tug of war race right here. Tug of war is not even a race.
It isn't.
No. But we've got infinity using its might to pull in one direction, and then we got 0, the ultimate nullifier, trying to bring us back down. This is an indeterminate form. We've been here before. Put it over 1. Bring infinity to the bottom, and you get 0 over 0. Bring 0 to the bottom, and you get infinity over infinity. Infinity times 0 is just a multiplicative version of either one of those two quotient forms, okay? So now we have 4 indeterminate forms. 0 over 0, infinity over infinity, infinity minus infinity, and infinity times 0. And in each of those 4 cases, there's some type of like dueling going on between these great forces, 0 and infinity, okay? So, yeah, the answer is indeterminable in this fashion. It still may end up being D and E, but it may end up being 5 or 3. We don't know. So, dang, general cleverness. What are we going to do? What are we going to do? Well, let's think. Man. Some days you're the windshield, some days you're the bug. But you're always Eugene. You gave it away, right?
Yeah, no, they announced it.
I'm not gonna. Well, I didn't hear it. Now I'm gonna be walking around the game like, "What's up, Ethan?" Instead of like, "It's Eugene the Unicorn from Magic Land." Like, you ruined it for me. Hey, look, watch. If this were sine of x instead of 1 minus cosine of x, x over sine of x is 0 over 0, and that would be 1, wouldn't it? If it.
Yes. Yeah.
By them saying yes, suddenly made you understand. He had a question and y'all made him feel bad. So he went, no, what? Yeah, oh, yes, yes. It didn't help you understand why they were saying yes. Oh. That is not Sisu, Jackson. What I was saying is, if it were this,
Oh, yeah.
okay, yeah, then that would be 1. All right, okay, good. So now my question is, how can we legally turn a 1 minus cosine into a sine? No. If it were squared, if this were 1 minus cosine squared, then we can call it sine squared a la Papa Pid. Well, gosh dang it. Gosh dang it. The bell's going to catch us here, but we'll go ahead and set it up. In order to make that a 1 minus cosine squared, I need to multiply by a clever form of 1. That is what? 1. And this was a technique we learned in proofs. Plus, it's the what you get of 1 minus. The conjugate. And the product of 2 conjugates is the difference of squares. That's 1 minus cosine squared. Now on the top, I'm going to leave it factored. And I think, as Iron Maiden said in their first release off their brand new album that released a week ago tomorrow, the writing's on the wall. We're going to be able to figure this out. Okay. Y'all have a fantastic lunch, and I'll meet you back here in 30 minutes.